Let's go ahead and solve LeetCode 608 tree node, which is actually the first medium SQL problem we tackle on this channel. And in this problem, they basically gave us what is a tree, which we've seen so many times in Java before. Now, to be more specific, what they gave us is a tree table, obviously, since it's an SQL problem. And within this tree table, they gave us two columns, ID and PID, which stands for parent ID, and this will make sense later on. And they also describe what a tree is composed of. So if you don't know, a tree has three different types of nodes. The first node being a leaf, the second being a root, and the third being inner. If we want to be respectful, I guess, to the order, it's actually root inner than leaf. But basically what this means, if we have a tree that looks like this, the very first node in our tree, where all the other nodes branch from, this is our root node. So it's the very first node in our tree. It doesn't have any parents, or it's not derived from any other node. This is the first node in our tree. Now, leaf nodes, on the other hand, are the last nodes of each branch of a tree. So for a leaf node, it doesn't have any children. It doesn't have any nodes that come after it. So in this example specifically, node 1 is a root node, while nodes 3, 4, and 5 are all leaf nodes. If you notice, nodes 3, 4, and 5, no other nodes come after them. They are the final nodes in their branch. Now, inner nodes are nodes that lie in between, I guess, between root nodes and leaf nodes. They do have children and they do have parents. So in this example, the 2 is a inner node. And what's asked of us to do in this problem is, given a tree table that has those two columns, ID and parent ID, we need to output this table and identify what each node in our tree is. So to illustrate, node 1 is a root node, nodes 3, 4, and 5, these are our leaf nodes, and node 2 is our inner node, and that's exactly what we returned. The type of node for each ID. Now in this problem, we're going to be tackling some expressions, some functions that we haven't seen on this channel before, like subqueries. And with all that out the way, we can actually get started now. Oh, and before we begin, do you need help bringing a digital idea to life? From designing to developing a website or an application, look no further than Evolve Consulting. We work fast, we're affordable, and we even offer free consultations. We'll get your app running in no time. So what are you waiting for? Reach us on LinkedIn or through any of the contacts on the screen. Alright, now let's get back to the video. So like usual, the first thing we're going to do is we're going to see our output table and see what we need to return. So obviously we need to select the ID column from our tree table. So let's start with that. Select ID. Now before I continue, our output also displays type, which obviously does not exist in our original table. But what we do have is the parent ID column. So what we're going to do is basically we're going to be returning the parent ID table, but we're going to name it as type. But we can't just do that in a straightforward manner because there are some things that we need to do. And now would be a good transition to discuss what we need to do. And what we need to do is, first we need to discuss how we're going to identify if a node is a root node, is a leaf node, or is a inner node. So actually let's talk about our tree table. Like I said, we have a column ID and a column parent ID. Now the ID column actually tells us all the nodes within our tree, and the parent ID tells us the parent nodes for every node in our tree. So for example, the very first node in our tree, which is a 1, has a parent ID of null, which means it doesn't have any parents, which makes sense since it's our root node. Nodes 2 and 3 have a parent ID of 1, which makes sense since both nodes 2 and 3 branch from 1 and 1 is their parent node. And for nodes 4 and 5, their parent node is 2. And that's exactly what our tree table tells us. It tells us all the nodes in our tree and who are the parents of those respective nodes. So now how do we identify if a node is a root node, is a leaf node, or is an inner node? Well, it's the easiest to determine if our node is a root node because root nodes have a parent ID of null since they don't have any parents. And so every time we have a parent ID of null, that means we have a root node. What about leaf nodes? We know that leaf nodes do have parents, but we also know that they do not have any children. They're the last nodes in their branch. And so the easiest way to identify if we're on a leaf node is by checking if the ID of that node, of that leaf node, exists in the parent ID column. If it does, that means it's a parent to other children, which means it's not a leaf node. But if it doesn't appear in our parent ID column, it means it's not a parent to any node, and therefore it's a leaf node. And obviously, if our node is not a root node and it's not a leaf node, then otherwise it's going to be an inner node. So going back to our query statement, what we're going to select is, like I said, we're going to select ID. Now the second thing we're going to select is actually a case statement. And the cases that we're going to introduce is whether we have a root node, a leaf node, or a inner node. But in this statement or in this query, we actually need to figure out if they are root, leaf, or inner nodes. So we're going to select a case statement. And the first case we're going to check is when parent ID is null. That means we have a root node. When parent ID is null, then this is a root node. The second case we're going to check, and this is where the subquery comes in, is we're going to check if the node that we're on, we're going to check if its ID is not in the parent ID column. And if it's not, that means it's a leaf node. And what that looks like in SQL syntax is the following. So when ID is not in, and this is where the subquery comes in, what we're going to do here is we're going to select the parent ID column from our tree table. Now, one thing we need to make sure of is that we don't return duplicates. So in other words, the only values we're going to return from this subquery are distinct parent ID values. And the way we do that is by using the distinct statement. So after we run this, what we get is null, 1, and 2. We won't return null 1, 1, 2, 2. And since we took into account the null condition, meaning it's a root, we're actually going to filter this subquery and neglect parent IDs that have a null value. And to do that, we're going to select distinct parent ID values from our tree where PID is not null. And so basically, if our ID does not appear in our parent ID column, then we have a leaf node. Otherwise, or else, we have a inner node. So at this point, we can end our case statement. And since we're selecting a case statement with these cases and we want to return it as type, what we're going to do is we're going to use the alias or as statement and name it as type. Now we're selecting ID and case as type from our tree table. And that's basically it. We can submit and see if our code works. Right, our table is called tree, not table. So let's submit again. And there we go. So that was the tree node problem on SQL. It's the first medium problem we solve on SQLs in LeetCode. I hope I made that problem a bit easier for you and you understood it. So I hope that video helped you, and thanks for watching.